All right, we're going to graph the functions for y equals the cosecant of x and secant of x. We can graph these functions by using the reciprocal identities. So the cosecant of x reciprocal identity is 1 over the sine of x. The secant of x, the reciprocal identity is 1 over the cosine of x. So we are going to be graphing y equals a cosecant of x by taking the reciprocal of the y values in y equals the sine of x. There will be vertical asymptotes that occur, and they occur at your x-intercepts of y equals the sine of x. If we graph the y equals the secant of x, we have to take the reciprocal of the y equals the cosecant of x. And we're going to have vertical asymptotes for the secant of x at the x-intercepts of y equals the cosecant of x. So we're going to go ahead and look at the characteristics of our secant of x and cosecant of x. So for y equals the secant of x, the period is going to be 2 pi. The domain is all real numbers except for multiples of pi over 2. That's where you're going to have vertical asymptotes. Your range of values are going to be y less than -1 or y greater than or equal to 1. Your vertical asymptotes will be at multiples of pi over 2. This function is an even function and has symmetry about the y-axis. So here is what the function looks like. They're going to look kind of like parabolas. And how we get them is we first graph y equals the cosine of x. So here is our cosine of x function, which we've graphed in a previous video. And wherever we have these x-intercepts, we're going to create vertical asymptotes. And now what happens is you reciprocate between those asymptotes. So you're going to be going the opposite direction of those hills in the blue, creating these parabolas. All right, so let's go down to y equals the cosecant of x. Has the same period of 2 pi. The domain is all real numbers except for integrals of pi. The range is the same as the secant of x. The vertical asymptotes are going to be in a little different place. They're going to be at multiples of pi. And it is origin symmetry. So we first have to graph the inverse function, which is y equals the sine of x. So here would be the first revolution of the sine of x. If I go in the negative, so there's your sine function. Now we look at the x-intercepts. So here's an x-intercept, 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 x-intercept. And then we create our vertical asymptotes. So I'm just doing solid lines so you can see them and writing a little faster. Now between those dashed lines in the green, you're going to start to create your cosecant function. So you're going to reciprocate the hills. So if here's my blue hill, I'm going to go in the opposite direction, creating like a parabola. It's not really a parabola, but it looks like one. And so in between those asymptotes, you create these parabolas. And what's in the purple is actually your cosecant function.